Hi everyone to the Flux Dev Meeting, 19th of November, first week after KubeCon Atlanta. We are still recovering, I am at least. Um, a little retro, what happened at KubeCon. So we organized the first ever FluxCon as a day zero event. It was half day. It went really great. I was amazed by the talks there, especially from Morgan Stanley and British Telecom. Um, Morgan Stanley presented how they adopted Flux 7 years ago or something like that, and now they got to a point where Flux manages their whole cluster estate, 500 clusters, 500 plus clusters, and it does deployments of tens of thousands of apps across all their data centers and regions. So it was, yeah, awesome to see that, all the optimizations we built in Flux over the years have really paid off, and you can run Flux at massive scale with very little resource usage, almost no CPU usage, and so on. That's really, really nice to see. The talks are recorded, and we are going to publish a blog post with them. We also had Flux talks during the main event. I did a talk with Tipti at the maintainers track, and I had another talk on the Flux MCP server and where we are heading with AI for GitOps. These recordings are not yet live, but once we have them, we are going to publish something and, yeah, let people know where they can see them. Other things, what's happening right now this week? Mateus has been working really hard on shipping the next patch release for Flux. Someone reported, for example, that we updated the Azure SDK, Flux controllers, and that version that we currently use broke. Flux cannot connect to the Azure China regions. So Azure made a fix in their SDK, and we are now rolling out all the Flux controllers in the patch release, and this will restore operations with China. Of course, there is no way for us to test this. I mean, Asia, China is a different region. We don't have any credits to run there, and we don't have the time or dedication to test all these different variants of Azure Cloud besides the main one. So we have a sponsorship through GitHub security team, where we now have credits for 2 years of running everything on Azure. It's enough money. That's not the issue, but the issue is, going on all these special regions. So yeah, things like that could happen in the future. We basically rely on Azure itself to do proper testing of their SDKs, and if there is a bug, we can, roll a patch release like we are doing today. Other things that are included in this patch are some fixes to our RBAC. So we introduce source watcher and artifact generator as a way to, to deal with huge Git monorepos. At KubeCon, we talked to Flux users who already have rolled out source watcher and the artifact generator in their production systems. I've seen someone showing me graphs on it took 10 minutes before to reconcile all the things from the monorepo. They have hundreds of apps there, and now it takes 1-2 minutes because the artifact generator basically helps you um, split the monorepo into individual internal Flux artifacts. So if you have 200 apps, you only change one or two, only those apps will actually get rolled out instead of doing a whole drift detection for the whole cluster. It was really, really nice to see. We released Flux 2.7 2 weeks before KubeCon, and at KubeCon there are already users running this in production. They are very happy with it. We got some really nice feedback about artifact generator. Everybody's happy with it. What we need to do is work a little bit on the user experience in the CLI. Users were saying we would really like to build the artifact generator locally and see how all these artifacts are being generated. This kind of feature, I don't think we have time to get it in 2.8, but it will definitely be added to our roadmap. So going back to the patch release, what we missed when we released Source Watcher was the cluster role binding that allows Flux tenants to view artifact generators. So Mateus added this permission now. Right now, unless you are a cluster admin, you cannot, even if an artifact generator is in your namespace, you'll not be able to view that object. If you have cluster view role through a role binding. So yeah, with this release, we are basically fixing that. Were there other fixes, Mateus?
Yes, there's a few more. So there's the one we did this morning for so we introduced in 2.7 the config map and secret watchers, right? In customized controller, helm controller, and notification controller for the receiver controller that uses secrets. And there's people who run Flux with namespaced RBAC at the controller level. So like the controller's accounts are not cluster admin, right? They don't have cluster scope permissions. They have namespace permissions. And this feature cannot they didn't have, like, for example, they had cluster scoped RBAC for watching Flux resources, but not secrets, right? It's part of their security stance not to have cluster scoped secret access. So we are introducing this feature gate in the three controllers to be able to disable that feature. It's a disable feature gate. So, and this feature gate is not, it is disabled by default. So the feature is enabled by default, right? You have to, so basically you have to opt out from the feature to fix your setup if you are facing this issue and would rather not benefit from the feature. And the recommended way to run Flux is with cluster admin and impersonation. So here's the recommendation.
Yeah, so they are not using Flux multi-tenancy and impersonation. They have this very custom RBAC. I hope no one does this. And
Yeah.
you need to look into Flux docs and understand how multi-tenancy work. The Flux multi-tenancy has been, looked into by various security companies, also tax security and so on. There is really no reason to mess up with Flux RBAC. You should be using impersonation. Anyway, for those that do that, you can disable a feature, but disabling the feature, you are losing one of the most requested features in Flux over the years, where people are saying, I'm changing a config map, I'm using the config map as values from in a Helm release, And I want the hand release to do an upgrade instantly when the config map changes, not wait minutes, hours for the hand release interval to expire. So yeah, we are introducing this feature gate. I hope almost no one will have to use it, but to not break this use case where you do this custom rollback, this is why we're shipping this. Oh, another thing was right in the CLI, there was a panic when a customization or a hand release has a source of type external artifact. So when you use artifact generator and you split, for example, a monorepo into multiple parts, the Flux customization, of course, does not have the source. The monorepo has the source, the artifacts that the generator produces. Mateus, can you mute? Thanks. So the problem was that we have this flag, Flux reconcile hand release or Flux reconcile customization with source. And the CLI assumes that whatever the source is there can be reconciled, while an external artifact it can't, is produced by something else. So for now we are fixing the panic and we are saying with source is not supported for external artifact. But in the future we want for the CLI to be able to figure out that the external artifact is produced by the artifact generator, and the artifact generator has sources from source controller, and it should drill down into all this dependency tree and actually trigger a reconciliation for the monorepo source, for example. Right. So this is not something we can do now in a patch release. It's a lot of work here. We will create an issue to spec this feature in the CLI, and hopefully we can deliver it somewhere next year. Yeah, so I think that's about it. So this patch release will be the last one we do this year.
There's one more relevant that we can highlight here. It's that regression in Helm upstream that was fixed in Helm 3.19.1. So there was this schema validation error, most specifically no URL loader registered. So we're fixing this as well in Helm controller. There's a lot of people asking for that. And yeah, like from the most important fixes, I guess this is the last one. And there's like a couple of more fixes that are not really worth mentioning, like very small and not regressions. But yeah, so yeah, lots of
Yeah,
fixes.
so in a Helm chart you can embed a JSON open API spec for the values YAML. And for some reason, people use remote specs in there, which is very bad, in my opinion. Helm controller should not go outside the cluster over internet to bring specs in. This will definitely not work in any air-gapped environment and so on. So Helm controller still failed to validate. We have a flag. You can actually disable validation if you need, but my recommendation is, especially now with artifact generator, where you can rebuild upstream Helm charts, you should do this before it gets to Helm controller, like the vendor, the actual JSON validation spec inside the chart, and have it stored in there, so Helm controller not do any kind of external calls. This is
It does
also when
feel
I've
like the
seen
thing that
that.
it's the kind of
What?
thing that people should be shoving into a layer inside of a chart. Like that stuff should just be content addressable inside of an MCI repo. But it's not the way that it's done.
Yeah. Um, But it's quite concerning that all of a sudden you reconcile a Helm chart and it goes and does, get out of the cluster, downloads stuff that you don't know what's in there, how you can trust it. Can it execute something in there if you put, I don't know, some code embedded in, who knows? You don't even want to think about it.
Yeah. Yeah, and I think that that's why like this stuff should be part of the artifact and not like some reference, some random URI. Yeah.
Yeah.
So I agree with
Yeah.
assembling
So
and vendoring it directly into the spec or into the chart.
yeah, we have this security page in the Flux docs where we tell people what it means to run Flux securely. And I think now with this new discovery, we should actually add this recommendation there. Even if we never design Helm controller to do external calls outside the cluster, Helm controller should only talk to source controller and the Kubernetes API and no other thing. Now it can go wildly on internet and download various stuff. So one example, you can simply DDoS Flux by having a 1 gigabyte file hosted somewhere. That's a JSON validation, and put that as a reference in the chart. So we have various ways of protecting against huge chart files and so on. And that's all built into source controller, because in our case, source controller is the gateway from everything that comes from outside. Now, Helm controller has no such protections. I guess we need to work with the Helm team in V4 to be able to, cut the download while it's
Have
happening.
we validated that a large blob reference via scheme is doesn't actually hit some sort of limit?
I mean, there is no limit. There is a HTTP GET in the SDK code, right?
Yeah, and it doesn't have any overridden defaults or anything on that client that would close the connection over some reasonable value.
There is no such thing in the Go client. So we've built a streaming reader with limits in Flux itself to cope with that. So the Go client cannot do that by default. It's not as simple as saying max limit or whatever. I think what you are hinting at is there is such a limit, but in the HTTP server, not client, in the Go standard library. So in the server, you can set such limits, but not on the client. The client is very bare bone. But we've built this. There is a really good example in the Flux packages on how we basically start streaming our own Flux artifacts, and we cut off once you hit a certain size. And in source controller, we actually did this for the Helm repos, HTTP repos that have this index YAML, and we capped it at 50 megabytes. And people can, increase the limit size. And we do our own streaming of it and so on. So we already have the code that can do that. With index YAML, with a JSON, doesn't matter what the payload is. Now because this happens inside the Helm SDK and we don't have a hook into this, we should either contribute these limits to Helm itself, or like Mateus did with other things in Helm for allowing us to swap the client, say, okay, for when you download stuff from external, like use our own Go client, and then we can, use the same client to use everywhere, which has same defaults, it's safe, does not work with untrusted certificates and so on. So that's a thing we should be looking at some point, because it opens up attack vectors on Flux that we weren't aware they're there. I didn't thought.
took this down as a action item. Should we turn this into an issue or something?
I mean, before turning it into an issue, someone should read all the source code in Helm and understand exactly what's
Yeah,
going on.
to actually validate what's wrong.
Yeah. Right. Figuring out where that happens, when it happens, and so on. What we definitely have now in the Helm release spec is being able to disable validation. So in the security recommendation, I would say if charts have external validation schema, you should disable validation. You shouldn't be running this in production. Especially if you are air gap, this will fail anyway. And if you are not air gap, there is a risk that if you consume charts that you don't actually control, someone will reference to a huge file, and that could, increase the memory of Helm controller by a lot and slow it down and so on. I'm not sure if buffering happens there, but given the fact that Helm controller does not touch the disk at all when it works with Helm charts, this validation happens in memory, right? So the whole file is loaded into memory. So if this file has 1 gigabyte and the limit of Helm controller is 1 gigabyte, of course it will run out of memory. So that's a concerning discovery about this Helm feature that I wasn't aware. Like for example, for Flux operator and all the things that we have developed in the last 2 years, we ship Helm charts with schema validation, but the schema is embedded in the chart. I didn't even know it's possible to say, go to this URL and fetch schema from here. I assume it's not a thing, but it is.
That's admittedly a very strange feature when the chart itself packages everything about the values already. It's right there. You could have just not done that.
Yeah,
Not
I
sure
mean, maybe
why.
these schemas are huge, or maybe you have many charts with common schemas and you host them somewhere. Anyway, yeah, we really need to read all the Helm code, understand the use case, and figure out a way to protect Helm controller and protect our users from someone abusing this feature, basically.
It does feel like the kind of thing you would want to be able to turn off while still retaining local validation. That would be
No,
nice.
because the local, so the spec in the chart points to external things,
Yes.
right? So you can't say I'm running the validation with the local file. If the file has external reference, the validation will fail if it can't fetch that reference, right? Because there are like big chunks of the values YAML, which their spec, it's something remote, right? So it's a JSON schema validation will definitely fail because all those references are missing. There are also different versions of JSON schemas that you can reference there. It's quite a complex feature. We need to look into it. I'm not for making any assumption. But yeah, it's clear from their message that Helm controller, the Helm had the bug where the actual download didn't happen. So it downloads stuff. Yeah. Hey, last one. I don't know if you've seen what we have announced at KubeCon around the Flux status page. So we are going to ship a status page, a UI embedded in Flux operator starting this year. It's more about, having a thumbs up, thumbs down approach to the whole cluster state and being able to drill down into all the Flux objects and all of that stuff. It's definitely not what you've been building. It's not about, being able to exec into pods or looking at the actual workloads. This is, monitoring the Flux system, monitoring all the Flux objects, being able to quickly diagnose stuff from a Flux perspective. I would say our goal with this is to get it into a shape where it covers all the read-only features of a Flux monitoring platform. This one, you'll not be able to, let's say, click reconcile or stuff like that. And it's meant for, these runs where Flux operator runs by default. You don't need to install any other thing. It will just open the port and it will work there. And yeah, it's we hope this will be able at some point to generate LLM prompts for AIs using Flux MCP server, where with the major advantage of shortcutting the discovery part, where, if you ask an AI, hey, something is failing in Flux, figure it out, it will do like, it will create like maybe hundreds of MCP tool calls, and it will fill the context, eat so many tokens. So if the status page will basically know what's wrong, so it can ideally generate a prompt, so your AI with MCP will know exactly where to go do root cause analysis and all of that stuff. So that's the direction with what we are building. How are you doing with the capacitator project? How is that going?
Thanks for asking. So you might have seen that there is a split between the CLI and then the self-hosted, or like on a URL kind of approach. And then CLI, I see some GitHub stats on, every release is being downloaded, I don't know, like 100 times or something. And then for the self-hosted one, I'm running this closed beta, meaning anyone who wants to get access needs to message me. And I have over 40 of those people, like companies, who have messaged me. And it's been running since mid-August. And by now I'm trying to, follow up with each and every one of them. And of course, somebody moved on, somebody didn't finish, somebody is difficult to get hold of, but there are people who finished it and stuff. So 10, 20 companies that I know about. So it's early days, but yeah. And then, what I'm hearing is that people move away from the Vive dashboard, and that's sort of the trigger to find something else. And obviously the Flux blog and the ecosystem page is the entry point for my funnel. So that's just what's happening.
Yes. So you are saying you want to offer like a hosted version of this, and
No, not hosted by me. It's for them to host. So like
okay.
yeah. So
So
like
with the Helm release or CI repo, they install
exactly.
it. Right. Okay.
Yeah.
Cool. Yeah, I got confused about hosting. I was like, what? Yeah. Okay. Because then you like if a hosted version will might be like you would have access to all their clusters and all
No.
their secrets. And
No, it's for platform team members who want to offer something
yeah.
for developers. And of course, if they
Cool.
don't want, to join the beta, or I don't know, then they can just use it as a CLI. And that is sort of my little friction I have planted. Let's see. I mean,
Cool.
you have to make it sustainable.
Yeah. I wanted to ask you about, I know you've been working on this for a long time, and I also want to have this feature in the Flux status page where, so now we show the events for the Flux objects. Of course, we have the Go side, the Flux operator, which knows everything Flux, and we can, ship only the Flux events to the UI. And my My question is, have you figured out a way to do searching in events, or do you have a local database like a SQLite or something like this where you store them, or how are you dealing with this?
No, right now it's really just, streaming events from Kubernetes, and then it has of course like a shelf life of 1 hour or something like that. So like storing the events, I believe that would be required, if you want to provide like alerting or some observability or something, after it happened. So if somebody wakes up, goes to the office, and then looks at the events, probably they are already gone. So no, there is no solution to that. And yes, the storage would be a solution. I just don't want to go there because I believe people in platforms already store those events somewhere. So I would rather integrate with those solutions than store it.
So how do you do searching then? You download all the events in the browser? They can be gigabytes of data.
Right. I have not thought about that, no.
So currently what you are doing, you are like sending all the events to the UI?
I am streaming the events when the UI is loaded, and then I'm showing the last, I don't know how many events fit to my UI. So it's not searchable like in a historical sense.
Yeah. So what I've seen is that people don't actually store Kubernetes events
Okay.
because they are massively expensive. So if you go on GKE or AWS and you enable that, I've seen users telling me storing the Kubernetes event can be 10 times more expensive than running the cluster itself. So that's crazy. I mean, right? You pay, I don't know, 10K for the cluster, then you pay 100K to store the events. That's right. So yeah, I'm thinking of having something like what we do in image reflector where we use BoltDB and all that stuff. BoltDB is also used in no Bolt Badger, right, Ali? What do you do? Badger DB. Badger. So Badger is also used in a lot of other CNCF projects for open telemetry. It's like is a database that knows how to expire things. It's really fast. It stores only the index in memory and so on. You can persist it if you want or not. You can throw it away, and the pod restarts. So I'm considering doing something like this because I don't actually care for the Flux status page about pod events or deployment events and so on. Those are really hard to deal with because you can have, I don't know, thousands of those per second. And that will like DDoS everything. So yeah, I was curious how you are dealing with this. Right now, what I've implemented is wildcard search for Flux events and Flux objects, where you can say Flux star or star Flux star, and then it will give you all the events for involved objects which contain Flux or start with Flux or end with Flux and so on, right? So it's not Elasticsearch type of thing. It's just a wildcard because I think this is very useful. Like if you have microservices and you use a prefix or a suffix with the actual product name, you want to list all the events or all the objects belonging to that meta project. So having this wildcard search, I found it a major requirement. That's why I'm shipping it basically in the first ever version. But I think people will want to search in the events themselves, in the message body, like, I don't know, some error code or, I don't know, timeout error or whatever. So you can't actually do this with Kubernetes because, of course, Kubernetes is not Elasticsearch, etcd is not that. So I'm considering building like a real-time index somehow, and I'm not sure how, but I think that's a major feature I want to do for the Flux UI that we are building.
Makes sense.
Cool.
Then the problem comes like that you can't miss an event, so you have to sort of I don't know, catch everything, or if you are, I don't know, your component is not running and then you are missing for a minute or something. Yeah, so there are some questions there or expectations to manage.
I solved this in a very stupid way in my toy controller called Flux Event Relay that I built for Carpenter observability with EKS Auto Mode, where events are all you've got. By doing the leader election, and when I'm exiting, I write an annotation to the leader election, which you have enough time to do just about that and not necessarily anything else. But it lets you say, don't look back further than about a minute past this point. I mean, I'm copying the events. I don't think you'll copy the events. So by copying the events, I can be sure that I'm not duplicating any, because I'll go and scan back that 1 minute prior to the timestamp just to see if there are any duplicates, but I'm not sure how you'd solve it without a copy.
Oh yeah, I mean, events are Kubernetes objects. They have unique IDs. That will be the key in Badger. So they'll never end up with duplicates. We are going to use control runtime priority queues. And when the controllers start, we are going to give priority to events in the last whatever minutes. And then deduplication will happen automatically in the in-memory database. There are many solutions on how to recoup from not seeing events. I also don't think this is critical. I don't want to treat this as this is not a Kafka type of installation. We do have persistency in all the objects. All the Flux objects have a persistent state, the status. That does not get lost. So the last thing that actually happened is in the status, right? So I'm not concerned about what's the current state, what's happening right now. It's more about being able to store like a history. And we also have expanded all our Flux custom resources to have the status history section. All of them have it now. And we've built this for Flux MCP for AIs to be able to figure out flipping states. For example, if you look in the Flux operator Flux instance history, it will tell you I have failed for 2 days installing this version. I have retried 10,000 times. Then at some point it healed. It's a different entry in the history, different shot, different version of Flux, whatever, different configuration. And you can actually draw a history graph of what happened with that particular Flux instance. And I've shipped this also in Flux customized controller. Helm controller has this for a long time, the history. But the history will tell you like the states that it went through. It does not have the actual errors and so on, because those can be huge. Like if you apply 10,000 objects and try run fails for 5,000, you'll have like events maybe over 1 megabyte. You can't store that in the status of a custom resource. So what I'm based on this history, what I would really like to do, like the history is persistent. The last state is definitely there in status along with the message, so you don't have to worry about that. But showing an incident that happened Friday night and you go to the job Monday, those events are gone, right? Maybe logs are gone as well, depending on your log retention, whatever. So maybe the UI can dedupe all these errors and have this lightweight database where it's basically I can point from the history to a segment of the events, which are, let's say, compressed, something. So you can actually show the actual error that happened, even if now it has recovered. Because that's another thing I've seen with people running Flux at massive scale, hundreds of clusters. It goes down in the weekend, Monday is recovered. But you really want to do a root cause analysis. Hey, what happened? Why it went down where maybe it's not that important the weekend that it went down, but for some businesses it is, right? So unless you spend millions on observability and everything to store all the container logs, all the events in the cluster and so on, unless you do that, you have no context whatsoever from Flux. You know that it failed, you know that it recovered, but what exactly failed and how it failed, no clue, right? Because we can't actually store this in the status of the custom resources. So yeah, maybe a lightweight database that knows how to do compression and duplication of events, because you can have millions of events that are actually about the same thing. All right. And especially with the Flux events, we have control over them. We know what all the controllers issue. So based on this experiment, if we decide, hey, the controllers, maybe they can be better at issuing these events. So optimizing how we issue events in order to be able to store them in a compact form, that could be something for next year to think about. And it's not only about the Flux status page. I think everybody will gain from this kind of observability in the future. Another thing that we also created an issue yesterday talking with Mateus, and so we have this inventory in the status of a Flux customization, right? Just doing a get of a Flux customization, you know exactly what objects are being managed in the cluster or in the remote cluster. While for a Helm release, you need to query the status, find the revision of the release, then go on the cluster, pull the Helm storage, which is a secret. So you need to read secrets all of a sudden. In the secret, there is a tar gzip. You need to untar it. Go over huge amount of YAML because everything from the chart is there to figure out what's the name of your deployments, your services, and so on. And even then, that information is not enough. They are missing namespaces there because the namespace comes from the Helm list. So even if you look there, you don't know in which namespaces there are. You need to do a whole bunch of discovery around that. And the Helm storage misses CRDs, of course, because Helm decided we are not going to deal with CRDs. They are too complicated, so we skip them. CRDs are not in the storage, but Flux Helm Control manages CRDs. So what we had to do in Flux 3 command, where we show you all the things that Flux manages, we had to query secrets. We had to query all the CRDs, filter all the CRDs by Helm release labels in order to tell you, hey, these are the objects that are actually came out of the cert manager Helm chart. There are 5 CRDs, cluster all bindings, deployments, all the things. And it puts a lot of pressure on the cluster every time you want to look up what's actually managed by Helm chart. And what we really struggle with is that secrets can be millions in the cluster because Helm uses it for storage, they are versioned, and so on. So we can't actually cache secrets. Let's forget about the security aspect of caching. or config maps. We can't cache those, right? So every time you want to look up and see what's in a Helm chart, you actually need to hit the API, query all these objects, and do all sorts of very expensive operations like untarring, looking up, query all the CRDs. That's the most expensive stuff you can do with Kubernetes. If you have something like Crossplane and have like 5,000 CRDs, doing a get CRDs is very impactful. So due to all of this, I have proposed, and I think Mateus and Lee and all the other Flux core maintainers will agree, we should add status inventory to the Helm release. Because the controller, every time it applies something, it knows which CRDs I have applied, what objects were in the chart with the namespaces and everything, right? So you actually have all this information in Helm control in the same way we do in the customized controller. So in order to, simplify this discovery and observability, we should have status inventory. And that means you'll do a single query, you get a Helm release, and you actually know, okay, these are the objects that are managed here. Then you can go and look these objects up. Are they healthy? Whatever. I know, Laszlo, I know you are doing all sorts of, here are the pods from this Helm release and all that stuff. But just the discovery of what are actually the workloads that Flux has deployed is so complicated for Helm releases. And it doesn't have to be this way because we own Helm controller. We can actually set the inventory there. And
And finally queue all this code that is spread everywhere for traversing the tree of a Helm release. And finally can just look at the status like it does for customize.
Yeah. If you look in the Flux CLI, it's so much stuff there. And we have it in the Flux operator. We have it in so many places, right? Yeah.
Yeah, and for end users, they would have to be able to read the secrets for the
Exactly.
Helm releases. So if the user doesn't have the RBAC, I don't have a tree. So I have that problem.
Yeah, of course. Another thing, if you look in the Flux tree code, you'll see that it will never work. It will never give you the inventory of a Helm release if the Helm release have a kubeconfig reference. If it does remote apply, because the CLI has the kubeconfig for the management cluster. There is no way I can reach from your local computer to some air-gapped cluster somewhere where only the management cluster has access to, right? So when you do remote applies, it's impossible to figure out what Flux is managing there. There is no tool out there that can tell you, because there is a huge disconnect between the storage secret, which is stored in the remote cluster, and the management cluster, right? But Helm controller actually knows what it has applied on the management cluster, so it can write the status inventory, and all of a sudden, we can tell people when they run a Flux tree on the management cluster, these are all the things that we manage everywhere, right? So that's a huge improvement from my perspective also to the current CLI. Even if, let's say, secrets are not an issue, everybody has access to them and so on, they still don't work when you use this remote cluster, hub and spoke mode. And having the inventory will definitely solve this.
So the storage secret is always stored in the target cluster?
Yes. Because you want on the target cluster to do Helm ls, Helm get,
MLS. Yeah.
right? So
Right.
we project the storage there and everything. And it's the right way to do it, because when you connect to a remote cluster, right? If Helm controller has deployed Helm releases there, you should have the storage there, not in the management cluster, right? So we try to improve this way of, okay, I'm connecting to the actual cluster, I can do all the Helm discovery stuff, but on the other hand, we have crippled the observability of the management cluster because we can't reach those. So now if we actually have an inventory, that problem goes away, right? It's one API call, then you know everything, even if it's local or remote or however you've set up Flux. So I think we should really strive to get this into Flux 2.8. It should be actually easy to do it. just in the apply area when you do install or upgrade or rollback, right? We have those objects there. We know exactly what they are because we also have post renderer. We already, have them, and we can mutate them and so on. So Helm controller is well aware of what it applies, right?
Yeah.
It's just a
I
matter of
actually had some questions of the details of the implementation of this feature. So for example, of course, Helm controller knows what it's applying and everything, but is this hidden on the depths of the SDK? For example, you just mentioned the post renders. I think the post renders are actually a feature from the SDK, right? Like it's not like we implement the post renders ourselves. Is that correct?
Yeah.
So yeah, like I'm wondering exactly how the SDK exposes the resources for us to store in the status. How does that actually happen? But in the worst case, we could just do what we're doing everywhere, but in Helm controller.
Helm
Which
controller
could-
manipulates the storage, right?
Yeah,
Helm controller reflects the storage of
Yeah.
of the Helm release into its status, some things to keep track of it, right? So we have the storage already loaded in memory. We have all those objects.
in memory. Nice.
Right?
So we just have to.
So we can just iterate over them if there is no other way in the SDK to get the objects.
So do we like parse the YAML? Because in the storage
We definitely
has
parse it, yeah.
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 It's already in YAML, right? So we have to parse it
Yeah.
again and do everything.
Yeah,
And
I
how
think
about
I think we can get a list from the install and upgrade commands, actions of what it has been applied. Because Helm from install and upgrade, then it sends this to the wait command,
right?
right? So it must expose them somehow.
No, but it's internal, right? Like the code of install and upgrade. Like I read this, like it installs and waits, it upgrades and waits. So it doesn't go back to us. So maybe at least from this place, this is not exposed from an SDK user perspective. But if you,
You
but
need
you
to
said,
you need to look into it. Maybe we can make it expose because this list is like we don't need a YAML back. We just need the
the list of
time,
resources,
namespace,
yeah,
API
the fully
version,
qualified ID
right?
or key
There are like
of the
4
object.
strings.
Yeah.
They can return that to the action or have some hook.
Yeah.
So I say look into it. See, I think the actions should expose that. If they are not exposing it, of course, we have access to the story, so we can parse everything, have basically the same code as in the CLI but in Helm controller
Yeah.
right now. But I would really like to avoid reparsing again all the YAMLs. The actions know them. So
yeah.
let's find a way with the Helm
Yeah.
team to make this.
The ideal way is definitely like making the SDK expose what we need, because that's the most efficient way from compute perspective, right? So maybe
Yes.
we can try that alternative. And another thing that I
Yeah.
was considering is
Oh,
about
and
the
one more
discussion we
thing.
had. So, okay.
We apply the CRDs directly. So for the CRDs,
Right.
we know them, right?
Yeah.
This is only about what's stored or what ends up in the storage. But for
I think
CRDs, we
do
can
that
add
with
them today.
SSA. Like I think we
No, we use the Helm client. We build them and we pass it to the Helm client, right? But we know them because we manage them 100%.
Okay. Yeah, and another thing I was thinking is that discussion we had in the issue about hooks, like jobs and pods being ephemeral and everything. That's definitely a good point that because they're ephemeral, it's wrong to add them to the inventory field. But
They are in the history. They are in the history. So the name
yeah?
of the pods, yes. if you enable testing and hooks, you'll see them in the status history with the name of the pod and the result of the exit status code.
Nice. So we have that structured information with fields
Yeah.
already.
So you know that a pod was created or a job created a pod that Helm deletes afterwards, but we leave the trace in there in the history. Of course, those things don't stick around. They are deleted, right? Because otherwise we couldn't do rollback, we couldn't do anything. But funny enough, those things that are ephemeral are being tracked in the status, while the things that are not ephemeral are not being tracked. So that issue is, track the actual things that get deployed. Yeah.
Nice. Yeah, because what I was gonna say is that even though they're ephemeral and should not be in the inventory, the observability for them is still desired, right? But
Yeah, we have it.
this problem is solved a long time ago.
Yeah. We have the list of jobs and pods name that have run, and we tell people the end result, right? Because if you can with Helm control, you can say, I want to run the tests, but I don't want to consider the test being a gate for the rollover. So you'll not trigger rollback. It can run the test can fail, and you store in the history what was the result of the test, right? Also with hooks, you can enable, you can disable them, and so on. So we have a good observability around that because a lot of people ask for all these features. And people also ask for, I want to know the list, and we told them, hey, you should do Helm LS or whatever. But from our tooling perspective, especially the CLI, this is like so complicated, right? With the secrets, with you need custom RBAC, it will not work with remote clusters. So yeah, I really think, Mateus, you should add this to your list of things for 2.8 and figure out where is the best thing to implement it. Is in the SDK? Should we do it on our own, and so on? But whatever we decide, I think it will pay off in the end to have the inventory and status, no matter how we do it, just for the added observability, and all the tools around Flux will benefit from it.
Yeah, and just to confirm what you
Even
already
doing
said here.
kubectl get, right? You'll see in the status all the things that it manages. Like you don't even need tools. Like even kubectl
Yeah.
get will be like so helpful.
Which honestly what I use the most. Like for
Of course.
reading operations, I use kubectl. For reconcile, suspend, resume, I use the Flux CLI, Flux operator CLI. But honestly, to read stuff, it's just kubectl. Yeah, also to confirm what you said, I can see in our code here access to the name of the CRDs. So like when we look through all of them for applying, we do already have access to them. That's
Yep. Yes, yeah, these are definitely there. I know that code. The other things are more. So you should assign yourself to that issue. I'll leave you 1 week to think about it if we add it to the 2.8 roadmap or not. Right? I don't want to put pressure on you today, but I'll put pressure on you next week.
we're gonna Capizawa is gonna have some time, so and he's interested in Helm 4.
Oh, nice.
Like I'm thinking
Okay.
that so like in Helm 4, I'm thinking that maybe it's probably gonna be 1 PR per repo. But there's all these other cool things that we are doing around and that are coming with Helm 4. Like for example, the feature for cancellation. I can assign that one to him. Like, I mean, the PR. I did a scrappy
Yeah.
PR to test it, but I can like maybe delegate to him the implementation of the whole thing with tests and everything. And also this one, it's one that we could delegate to him probably because I'm feeling that we may require some improvements in the SDK for implementing this feature in the ideal way, which is exposing the things we need without reparsing YAML and everything. So that's going to be a Helm 4 thing as well. And since he wants to participate on Helm 4, honestly, I can like
yeah.
leave him the fun part, which is these new features. The cancellation is a new feature. This feature we just discussed is a new feature. And the, tiresome part with just migrating to Helm 4, I can like it has to be probably 1 PR per repo anyway, so I can just do it myself.
Yeah, source
So,
control
yeah.
and helm control, right? Source control first.
Yes.
And we
Maybe.
hear me out. We also have to figure out. I deleted a bunch of code from, and it may be rolled back in 2.7, right? All that legacy code that I've deleted, that it deals with the authentication and verification of charts. Where we have like this, we instantiate the clients again to the verification, and I've deleted all that code, and it worked, right? And you said, "Oh no, let's put it back." I'll give you the pull request. Let's put it back, and we do it in 2.8. So that's also something that Kapizawa mentioned when he did the secrets refactoring. Then that all this stuff is no longer needed, right? So
Right.
maybe he should also pick
Right.
that
No,
up.
yeah, now I
The
remember.
refactoring
Yeah,
and
now I
to
remember. Yeah, now I remember what you're talking about. Yeah, that directory, that's in source controller, right? Like that directory that is
source control,
created
yeah,
and everything. Yeah.
all that
Yeah,
stuff.
yeah.
Like I managed to delete all that code. We never touched the disk, and it actually all the tests work, all the verification, everything, right? So it's definitely
But
possible.
I convinced you
It was
not to do that,
dangerous.
right?
It was like
Yeah.
2 days before the release. It was,
Yeah.
I agree, it wasn't the good thing to do because who knows what's in there. But I
Yeah.
think we should actually go back to that and remove all that stuff from source controller, because it not only complicates code, the fact that it touches the disk, it puts more pressure on the disk. Why
Yeah,
are
no,
we
we're gonna
even doing
definitely remove that.
IO? Yeah, when we can do in memory. So
Like, I'm not sure because
I
your
think
solution at the time involved moving the TLS part to another part of the code, to the like
yeah,
OCI registry or something. And you pointed out that we have these in two places. So why, right? Like, why do we have this thing that writes the TLS stuff into
certs,
disk
yeah,
and the OCI stuff? And you said no, we just need the OCI stuff. Yeah, so we need to figure out if we really need, if just like the tests are passing, right? So maybe, yeah, we can just remove that. But if we don't, if we can't remove the TLS part as well, at least there's a feature that I shipped in Helm for not needing disk anymore. If there's a reason for needing that, at least it doesn't need to be on disk anymore.
yeah, definitely. Like we can load the charts in memory, right? And this was a major requirement for Helm control, because in Helm control we don't touch the disk, right? We stream the chart from source control into memory, and we do all operations into memory, don't touch the disk, and
But
then
this is in source
we
controller.
release it.
But
Yes.
this is,
And source control does a bunch of
I'm saying that
disk
we don't need
operations,
to.
yeah, which are not needed. For sure they're not needed if the SDK allows us.
Yeah. So that's an improvement I
Well,
did in the SDK. If we still need that TLS stuff, that could probably be just what you said in the OCI package, right? If we need that, if we still need that, then at least it won't be touching disk anymore, that part.
yeah, writing certs on disk is like horrible. We shouldn't be doing it.
Yeah.
Cool. Okay, we are over time, and I have another meeting. Yeah, let's catch up next week. Okay. Well, nice seeing you, everyone. Have a nice day.
Thank you, guys.
Good
Bye,
morning,
everybody.
Kingdom.
Yeah, good morning.
Thanks,
Good
everyone.
evening.
Did you guys start an hour early today?
Yes.
Oh, okay. Is that
The
going to
time
be
with the time
a
zone
regular time?
change. No, the time zone has changed. Um
We're in that weird period of time where the
Oh,
daylight
okay.
savings time in one place is
Daylight
not
savings.
the same as daylight savings time in every other
Yeah.
place.
So Europe starts earlier. So this is the right time. We didn't move anything. You're late.
Yeah.
1 hour.
All right.
Okay.
All right.
But that's
Okay,
that's
have a
only
good
for
day,
this
everyone.
week.
Bye.
For next
Bye.
week, it'll be on the Europe time.
I'll make sure the meeting is posted if you want to catch up.
Yeah.
Yeah, okay, that would be good, Kingdom. Thank you.
Okay, cheers.
All right.
Bye.
Okay, bye, everyone.
Cheers, everyone.